Hi, I'm Miss Vynette from the Poplar Creek Library, and today I want to share a couple simple science experiments with you. These are items that you can find around the house, and so I'm going to get started and show you what items you're going to need. One of the items you're going to need is wax paper. If you don't have wax paper, these little foam trays you can get from the store, these will work great. You kind of need a slippery surface. A toothpick, so you might have a toothpick at home. If you don't, a wooden skewer will work fine. I'm going to be using an eyedropper, and I know that's not a common thing you usually have at home, but if you have a straw, that will work well. You can just dip it in the water, holding your finger over, lifting up, and then releasing, and you'll get drops. And you need some water. For the purpose of this experiment, I colored my water, and that's only so you can see it on the film. You do not need the food coloring for this experiment. So let's get started. I'm going to show you the experiment, and I call it the moving drop. So we're going to learn a little bit about water molecules. So I'm going to take my dropper, or if you have your straw, you're going to fill it up. And on my wax paper, I'm just going to put dots all over. It's really cool. You can make big ones, little ones, kind of put them all over. Notice how they have that dome shape. And that is because of surface tension. And we'll talk a little bit about that too. So the next thing I want to do, I told you you need a toothpick or a wooden skewer. I'm going to wet that in my water and get it really wet. And what we're going to do is we're going to show that water molecules have a really strong attraction for each other. So if I put my toothpick close by, you'll see how it jumps to my toothpick. The reason being, water molecules are attracted to each other because they have a positive and negative charge, and opposites attract. And some people call water sticky, how it bonds together. And you can move them around. It's not wild. I'll get some more water. And when they're, so I'll try to get them really close together, and they just bounce on each other. So just something this simple shows you some properties of water molecules. And I want to show you, this is something you can take further. I made a water molecule out of beads. You can use pom-poms, anything, just to demonstrate. You have one oxygen molecule, which is a little bigger than your two hydrogen. And you've probably heard of hydrogen bonding. So this has a negative charge, and the hydrogen has a positive. So they're going to bond together. So if you look, all these molecules, they're bonding all over, and they're really sticking together. This dome shape shows surface tension, where they're pushing on all sides and up from the bottom, causing this dome shape, which shows the surface tension and how cohesive those molecules are. I'm going to show you something. I'm going to put my cotton swab in some dish soap and watch that dome shape, what happens when I hit it. See how that just spreads out? I've now disrupted the surface tension with those soap molecules. In our next experiment, I'm going to show you something more, another reaction with the soap molecules. So stay tuned for that. For this next activity, you'll need some different materials. You're going to need some milk. For mine, I grabbed some whole milk. You're going to need some dish detergent. And definitely for this one, you need some food coloring. I also grabbed some cotton swabs. Then you need something to put your milk in. You can use a bottle top. I'm using a small dinner plate. You can use a bowl, anything to pour your milk in. So let's get started. First thing you need to do is pour your milk. So I'm going to pour it into my dish, and you probably want to fill it to about a quarter depth, just so you're covering that. And I'm going to, just for fun, fill, this is the top of a giant bottle, so that'll work well. And you want to let that milk settle before you add your food coloring. So, and we're going to add it to the center, so I'm going to put some drops in the center of these. And I would say use 4 colors. You can use as many as you want. And we're just going to kind of put that to the center of our milk. In our last experiment, we showed how our water molecules are attracted to each other. And milk is mostly made of water, but you also have vitamins, minerals, you have protein, but you have fat molecules in milk. So that's a little different. Now we're going to take our cotton swab, and we also showed when we dipped it in detergent what happened to the water. So I'm going to do the same thing. That's why we have some kind of detergent. I'm gonna get my cotton swab all wrapped up in detergent. And I'm not gonna stir it. All I'm gonna do is touch down, and I want you to watch the reaction. Wow, isn't that cool? See all that movement? Almost like a fire. I just hold it down and watch how everything's moving around. What's happening is the soap molecules are running around, attaching to those fat molecules. At the same time, they're also, I'm gonna do another one and hit it in another spot here. At the same time, soap is also repelling that water, and it's also going around and grabbing onto that. So you have a lot of movement. Our food coloring is showing the movement of all those molecules swirling around, attaching to each other. Again, soap molecules are electrical particles in there. So they're attaching, they're repelling, and they're also attaching. Isn't that cool? So it's a fun experiment, and the food coloring is allowing you to see all the action of molecules being attracted to each other, grabbing on to each other, and also repelling. So your soap molecules will show a different chemical reaction. So this is something fun that you can do at home. The movement will still go, but once all of that is mixed together, your soap molecules with your milk molecules and everything, that action will slow down and it'll blend. Try something. There's something you can take it further. Will it make a difference on what type of milk? I used whole milk. You're going to have more fat in whole milk, just like oil. They don't mix. Maybe skim milk, you're going to have a different reaction. A heavier cream. Try different milks. You can also try different detergents. I happen to be using a super strength Dawn, and that might cause a different reaction if you use, other than using shampoo or maybe a milder soap. So take that further and experiment with that. Okay, thanks for watching the experiment. I hope you enjoyed it. We also want to share with you some different books that you can get at the library. Poplar Creek Library has lots of books on science experiments. I love this one because it actually tells you what is happening, how come that's happening. We have several different ones with easy science experiments that you can do at home. The color changing milk was taken from this Steve Spangler. You may have heard of him. So many books that you can get at the Poplar Creek Library. We also have resources from our Scholastic, and I'll show you some of those if you want to take it further. Our Scholastic educational worksheets, you can find them online at the library. This one takes it further with another water experiment using pennies. So there's several different activities that you can do that we offer. We also offer Canopy and Hoopla, where you can get other books, and we also have some movies that will show some science experiments. So keep watching for more activities at the Poplar Creek Library. Thank you.